Welcome to the Data Science A to Z Theory and Programming tutorial. In this short video, I will show you how to do matrix operation with randomly generated uh, data and from Excel data file. So in one of my previous videos, on these videos, I showed how to do uh, basic matrix operations. So for instance, like matrix addition, matrix subtractions, matrix multiplications, matrix inversion. But in data science, in reality, actually, there will be a few rare cases that you will get like this kind of small and predefined or fixed array. But most of the time you may need to generate your own data matrix, or uh, actually most of the time you will get your data large data set in an Excel file. So let me start. So actually I have put all of my programs code in my CSITEd experts GitHub account, and in this project data science A to Z, and within this folder matrix and vector operations. So I have this project downloaded on my computer. So let me open this one. So okay, so this one, so let me open this with Spyder. So in previous videos I showed how to open Spyder. So then to file, then open, then let me open this one, matrix operation with randomly generated data. Okay, so since I have already this program checked, written and compiled, so in order to save our time, I just want to explain this program instead of composing this line by line programs. Okay, so here on this line, let me run this few course, and then you will see the output here. Okay, so let me clear the console and rerun it and get the, actually rerun this and get the output again. Then you will see, so this chunk of program course, it generated a random array. My array name is here my list, and here it generated 10 numbers. So this is why this is a for loop I used with the range method. The Python range method, it works in a way that in the parentheses you will give your starting value, and at the end after comma you will give your total numbers or ending value. But one thing that you need to remember, that in Python range method the starting value is included, that means 0 is included, but the ending value is excluded. That means the total number here is 10 will not be included, 10 will be excluded. So the list range, actually an array here, that will be starting from 0 to 9, because 10 is not included here. So 0 to 9. And then here this is the random method I have used here, x equal to random, then dot rand int. This method, it takes two parameters, the minimum number and max number. I have my min number is 0 and max number is 10 over here. So then this method works in a way that both min number and max number, the left argument and the right arguments, both are included. So the number will be randomly generated within my range, within my 0 to 10, and 0 is included, 10 is included. So my number can be minimum 0 and maximum 10. Okay, so then what I'm doing over here, so after generating each time, after generating a random number, okay, then I'm adding or appending that number to my list, my list by adding my list dot append x. So then after that, when I print my list, then it will print the list, this one. It has 10 numbers, you see, but since these numbers are randomly generated, so if I rerun this program by selecting and pressing Ctrl plus Enter, then it will generate another set of random numbers. You see that every time you run this program, you will notice that you will get a new set of numbers. But one thing that you can check, that your number will be with all of your numbers will be within the range 0 to 10. So okay, so here the codes are pretty simple. So now once you know these codes, if you need to generate a list of 100 numbers, then you will change only just here 10 to 100. Then if you run your program again, then you will get 100 numbers. Now if you need 1000 numbers or 10,000 numbers or 1 million numbers, okay, so then you will just change your total number and then you will run this again. So remember that you don't need to use comma. If you use comma, so then your program, okay, if you use comma, then your program will not run. Okay, so the comma is not accepted, so remember that you cannot use any comma. So the program codes are running, and remember that in order to use the random class over here, so we need to import random. So if you do not have this random method, just let me uncomment it. Okay, comment it out by pressing Ctrl plus 1. Then if I run this program code again, you see that it is showing me, actually before even running, it is showing me an error message that is showing that it shows that this undefined name random, that means random class is not imported, so I need to import it. Okay, so then if I press Ctrl plus 1, then it will be uncommented. Okay, now I got my code running. Okay, so that's good. So please practice this segment of code, then you will see that when you use random, for instance, here one thing that I can tell you, that once you click random and then if you push dot, then you will see the list of methods that the random class has. For instance, I wanted to add rand int, so this is the rand int method. Then I can select it, and then by this way, so you can see the all of the available methods in the random class. Okay, so I'm getting back to my code. Okay, now let us generate another matrix. Okay, for instance, let us generate a 10 by 4 data matrix X, initially populated with zeros. So this, my target here is to generate a random generate a matrix X with 10 rows and 4 columns, and then initially all of the values will be 0. Okay, so here my row count is 10, column count is 4, then my matrix X will be, so I will use numpy. Okay, numpy. So previously I showed how to use numpy. Actually this is the numpy library, so it's shortcut I'm using. I'm importing here numpy, and giving a shortcut name np. So instead of writing the full name numpy, I can use np in shortcut. So I'm using here x equal to numpy dot zeros, that since I am putting all zeros, and then this method, within this method I am putting row count and column count. What are my row counts and column counts values here? Row count is 10 and column count is 4, and I'm giving data type equal to int. Okay, so then if I run this program and then if I print this, so then it will generate a 10 by 4 matrix. There are 10 columns over here, 10 rows here and 4 columns, and initially all of these values are integer type and 0. So if I wanted to make these all initial values float, then I could do, for instance, I can uncomment this one. Instead of writing data type d type equal to int, I could write data type equal to float. So then if I run this, then all of my EC value will be 0 dot, that means this value will be okay, so will be floating or decimal number. So let me, for simplicity, let me keep this as integer. Okay, so by this way you can change your row count to any number, and then whatever number you give your row count, and then your matrix will be generated that way. You see that it is not showing over here all of the rows, okay, all of the 10,000 rows, but maybe if you give 100, then maybe you can see 100, you can see 100, you can see 100 there are 100 rows, but you don't need to count. Okay, so believe me. And then if you give instead of 4 columns, if you need 6 columns, then just change one at one place, you will get 6 columns. So this program code is very customizable, and you can change only in one point to change your matrix size, row and column size. Okay, that's good. So please practice this segment of code. And then now let us do something. For data science operation, you will mostly generate some random numbers, not only like this way, not maybe like this way, or no, you will sometimes generate distributed data. That means normalized data. For instance, in this setup, I say I want to generate a data, for instance, this is my problem. Let me see what is my problem. Let me explain it. Populate the first column with independently identically distributed, that means we say IID. Random variables is natural distribution in statistical term. Is this is means this mean is 125, and this is variance. Variance means standard deviation square of standard deviation is 16. That means standard deviation is, I'm counting here, standard deviation is 4, that means variance equal to 16. Okay, that will be simulating my height. Okay, so then I want to, in this, for instance, in this, remember that in this matrix, I initially put all of my rows and columns, that means all of my entries 0. Now I want to replace the first columns, the value of the first column, by these values, by randomly generated some values with this standard deviation will be 125, mean will be 125 and standard deviation will be 4, or variance will be 16. So that value I will want to put in column 1. Okay, so and in column 2, and that value I want to assign as height. So I want to assign as height, and then the second column I want to put this normal distribution. 125, that will be my mean, and then 64 will be my variance. Okay, so instead of, actually I need to put comma over here, don't be misled. 125. Okay, so how do I assign that one? So the trick is that you see that I will put my height will be my, this is my matrix, and then from the whole matrix I will take all rows, that means colon. A colon means all row values, and then 0 means the first column. Okay, in Python a matrix is array is counting from 0 index. So this value is 0 0, that means this is row is 0 and column is 0. For this value row is 1, column is 0. For this value row is 0 1 2 and column is 0. So all column values I will put, all these column values I will put as height. Similarly, the second column values I will put as weight. So this is why this column, this first column is in with index 0, so this is why I am putting 0, and the second column is index 1, and then for instance my third column would be index 2 and fourth column will be index 3, and so on. So if I assign this way, for instance if I assign this way, you see that, okay, I'm pausing this video for a minute. Please pause this video for a second and try to understand what will be your output if you run this. Okay, try to understand this. Okay, at this point all of my height and weight are 0 because I did not run this code, this code yet, right? Okay, so now I want to run that. Okay, for instance I want to do my weight height ratio. Okay, so now I want to implement this code. Okay, so in Python, actually in order to implement this code I need to do something else. Actually I have assigned declared another list here, is called a WH ratio list. I put a weight height ratio list. Initially I put all 0 by 0, and then I'm putting counting row count. What is my row count over here? My row count whatever here is 10. Then one thing that we need, this is the very important statement. You need to do this, remember this is a list, right? So you need to convert this list to an array. How do we convert a list to an array? So then you use numpy then as array method. So numpy np numpy dot as array method. So this method takes this list and then it will be converted this list into an array. So how in Python and in Spyder, when you select a method, how do you know a method? This is a method because it has a parenthesis after name. Okay, so the common way to know a method is after a method name you will see a parenthesis. So within a parenthesis you have, if you have something that are the parameters or argument, and sometimes you may not have anything within the parenthesis. Okay, so when you see a method over here, so click your cursor over here and press Ctrl+I. Then once you put Ctrl+I, then on the right side you will see the description of this method. What is the function of this method, what are the parameters of this method, and what is the return types, output, and an example as well, as you can see. Okay, then so for instance, if I execute this code, so then what I will get, I will get an array of size. What will be my size? My size will be row count is 10. My size is 10 over here. Okay, now actually I'm going to implement this code. So in order to implement this code, I need a loop. Let me make some space. So I need to run a for loop. Okay, so with for loop until this array size, that means it will go from 0 to 9. Okay, then okay, here 0 to 9, and then I'm putting every height 0, 1, 2 up to 9, or that at the end of the array index, and I will put num np.random.normal. This is the normalization method I will use. So if I click Control plus I over here, then I will see the normalization methods, normalization function in Python. The normalization method is actually Gaussian distribution. It's called Gaussian distribution, that is widely used and commonly familiar in statistics. You must be familiar with this Gaussian distribution if you want to learn data science. Okay, and I'm putting log equal to, so let me see the, you see the normal methods pattern or format is log equal to my mean value. Mean is 125, and my scale will be, okay, let us explain. My scale will be, what is my scale? Is standard deviation. Okay, my scale will be here standard deviation. Okay, then okay, my scale is actually standard deviation. Then actually I did a mistake over here. I need to put 4 over here, because my standard deviation, this is the variance 16, then my standard deviation will be 4, and then for this one my standard deviation will be 8. So I need to put standard deviation over here. That's a good thing. So then what I'm doing, I'm creating a random value within this normalize method, within this standard mean, and then 4 standard deviation, and assigning that random value to my height I. And similarly for weight I am using this method. Okay, same method, just with the change only in my standard deviation. So then, and then one thing that I can use this, I am putting this ratio, weight by height, weight I by height I ratio in this array. So now if I run this code, so then what I will get, this segment of code, if I run this, you see that this is my height. Actually this is my height, and these are my weight. Okay, since I'm trying to run print weight first, so let me go this way, print weight first and then print height first, next print height. So if I run this, then it will show me in just this way. Okay, now if I run this again, for instance, for every element within the array, if I want to print these by these and these and these, and also ratio of this and this, then I can do this quickly. And then what it is doing for it is for every index, array index from 0 to the last index 9. Remember that, you know that for array you will not have the 10th index. The 9th index is the last one. starting from 0 to 9 will be 10. So then you are getting here, you are getting, for instance, 129, the first weight, and height is 125. So then you are getting weight by height, that means 129 divided by 125 equal to 1.3.3 or something. That is very simple, that I am writing this code over here. So this segment of code is you need to practice this is segment of code, because it is complicated if you do not understand this. So you need to start from here. You see that it says weight is percentage d actually is used to print an integer number, and equal to percentage d. Since my number is integer, so I will print percentage d. So then I is my index and weight I is my integer weight. So if my weight would be float, then I would pay percentage f over here. Since here you see that I have percentage f. If I put percentage f, okay, then if I put percentage f, then my f by default will be, my value will be printed or displayed up to 6 decimal. If I want to print it up to 2 decimal points, then I put dot percentage dot to f, then my value will be printing up to 2 decimal points. Now, okay, in shortcut, since I have my weight height ratio over here, so instead of writing this part over here, I could write this statement. I could simply write this one. This statement is same thing over here, weight height ratio with index I. And if I run this code, I should get same result. Okay, so now, so this code will be available on my GitHub account, this repository, and within this folder. So please get this. Let me see. Okay, please get this code and do some practice. Then you will understand the basic operation of matrix with randomly generated data. You will see most of the cases, or some cases, you will need to generate random data. Mainly is for when you do practice. If you want to do practice in data science, then you need to understand how to generate random data set, because sometimes you may not get available data at your hand, so you can play with pseudo data. So then this is a good way to practice how to generate pseudo data and how to assign that pseudo data or randomly generated data into a matrix. So most of the thing that you can start from here with a simple random method, randint method. Okay, so if I press Ctrl+I, I can see it's this method's description. And then sometime when you become an advanced data scientist, then you will need to understand or do this kind of operation with normal distribution. So by using normal Gaussian normal distribution method. So I hope this video will help you. So okay, thank you so much, and in the next video I will show you how to use matrix operations with Excel data file, that you will get your data from Excel data file or a database that we'll see. Thank you so much. Thank you for watching this video.